How does an event go from Azure Event Hub into your event house? Not with a pipeline job that runs every hour, obviously, but in milliseconds, continuously. That's Eventstreams. Today we will learn about Eventstreams. We will learn everything they do for us. We will learn the architecture. We will see demonstrations, and we will talk about all the questions from the community. Let's go straight to the idea of real-time intelligence and event streams. So we have this idea of RTI, real-time intelligence, and in there we have the event stream no-code canvas. So, well, no-code is great, but can be a little bit painful when you need to do a lot of changes. But in this case, in my opinion, it's mostly great. So how does it work? We have this real-time intelligence area. Beside of that, by the way, we have the real-time hub. The real-time hub gives us a central event catalog for a variety of sources. But we have sources that will naturally connect to event streams, which is Azure Event Hub. I will abbreviate that with AZ, Azure Event Hub, which is the spooler for events in Azure. Azure IoT Hub. This is like a specialized event hub, mostly enriched with device management capabilities. Then we have Apache Kafka, which is a well-known event streaming platform. We have SQL. Change data capture, CDC, which is also streaming data. And we have, of course, sample data, which we will use today. So all these sources can go into RTI, real-time intelligence, and go through Eventstream. We have destinations. Where can we consume the output of the event stream? So first of all, of course, the event house. Our cluster with databases, KQL queries. First stop. Next possibility is, so we can deliver all of these, right? So I will draw it like that. It's Lakehouse. So we can push the data to the Lakehouse. We can push the data to Data Activator to derive actions out of that data. No? So something is larger than, something is less than, something is unusual, stuff like that. And we have custom app, which could be, for example, Kafka, or again, Event Hub. So these are our targets, right? So it's like incoming stuff. It's like RTI, and then it's outgoing stuff. So this is like routing. It's a routing capability for real-time data. That's the point. Let's get started with event streams. We have our Eventhouse infrastructure basically from the last video about Eventhouse with some sample data and the bike sample, and we will partially use that because it's already there and it makes sense. So this is like the environment that we have, a Fabric workspace. So let's move on and let's then create our first event stream. You see we have an event house and we have two databases in the analytics and demo database. So fairly simple. Let's create an event stream. We need, as always in Fabric, give that thing a name. In this case, it's bicycle telemetry data. And when we create that, we read it with our canvas, right? We can insert the sample data here. This is a bicycle sample data. You see it's on the left side. It's currently loading the data. And in the middle, you see the default event stream. So it's well, you see now we have the sample data, or a preview, a sample of the sample data in here. We can select from where to see that data, and this is the default event stream. It's automatically created. You see we can rename it, but it's in there. And you see the small connectors that connect all that stuff, and we have no target at the moment. So we could insert additional operations, and we have to define a target. This is a target place for the target. So when we, at the moment we run that, it ends up nowhere. It's like out to death null. Kind of that, right? So we do that, and now we are on the live view. The reason why we do that is that the event stream compiles the schema data while it was published. So you see we can activate or deactivate our data stream data. We have some data insights. There was obviously a streaming of 115 incoming messages at that point. We have published it, but it doesn't make sense at the moment. There is no functionality behind, which is okay. So what's the point? What's the capability of event streams? So we have a source again, a source of data, continuously incoming data, like events, right? Event Hub. It doesn't really matter. Something that streams continuously data. And then we are in the event stream canvas. Event stream. And it's like that. You draw stuff, right? It's no code environment. We have a default stream. The default stream is default by name. It's created automatically. It's raw events, and from there on we can either push the data directly somewhere, so it's unfiltered, or we can start to say, okay, we will filter that stuff. So for example, temperature must be greater than 80 degrees Celsius, or we want to group that data. Group by minute and region. Next step. And we can say, okay, from that on we derive a stream. See, this is a raw stream, and this is the filtered stream. And now we close the canvas and say, okay, there are destinations, targets, like an event house for real-time queries. We push that directly to a different event house, or we say, it's to Lakehouse because it's for long-term data. It's like archive, right? Lakehouse. There we go. Or you say, okay, it's Activator. We want to act on data. Go there, do something. So this is how it works. We push the data in, we filter it, we group it, or we just put it through with raw, and then we put it on the destination. That's basically how the canvas works. So let's have a look how this would work with, let's say, an event hub with 1,000 devices. I pre-created a graphic here so I can explain it a little bit more in detail. So from the Azure IoT Event Hub with 1,000 devices, we go into the event stream canvas. And there we have the default raw stream. This is the default raw stream. We can push this default stream forward to our event house in the table raw telemetry data, for example. It's direct ingestion. You just get straight the data. By the way, well, we will cover that in community, but you don't need to care about duplicates. Just saying that. We can also filter this raw stream by, I don't know, temperature. We can aggregate it in a tumbling window by 1 minute averages. And then we can write it to, let's say, an Eventhouse with telemetry 1 minute data. Different table after aggregation. You can filter something regarding pressure, right? And write it as historical data to the Lakehouse. Or we can push the raw data to the activator and we have an alert on anomaly. And this is the important thing here. There we go. It's simultaneously destinations. So you write all that stuff simultaneously. That's really cool, right? So that's the magic of the event stream. So let's put some functionality behind that. For that, we need to switch back to the edit view. You remember we don't have any target yet, and we have the different modifications, or we have the target. In this case, we select in target the Eventhouse, and we will go for direct ingestion, so we don't need to do event processing before the ingestion. So direct ingestion for our case, for demonstrations is the case. Nice. We select our Eventhouse, which is the RTA demo Eventhouse, and the KQL database, which is the RTA demo database. You see that we don't select at that point a table, right? Which is a little bit special. So let's save that. We have the target RTI demo Eventhouse with an Eventhouse and an event KQL database. And now we again need to publish that thing. And once we did that, the schema is processed again from the default data stream. And you see it's currently loading, right, on the right side. And we need to wait until this load has finished. And then you see we can hit configure, and it's pretty okay, but you need to know that, right? So it's unconfigured, and now you can press configure to configure the details of. Yeah, this is the configure button, the details, and that essentially creates then our table. And before that, we don't have any table target. So it's loading. Next we get a wizard where we can name our table. That's a table name. In this case, we will name it bicycle events. And we have the stream, the data connection name with some GUID suffix, and everything is pre-filled. So it's a quite big interface, but you can see we can check everything, and we can hit some advanced options there. We can select the format. In this case, it's JSON, and we can see the data, and we have this edit button. And once we press that edit button, I need to fiddle around a little bit with that interface. Now you can see it at least overall. We have this familiar Fabric interface where we can define the mapping, the color mapping from column name, type, source, mapping transformation, and so on. And we even get sample data for that. So that we can configure all that. Once we are fine with that, we can hit finish, and it will go through the data preparation, create the mapping, and create the data connection. For me, in my experience, is sometimes hang a little bit around, but it always worked. Like when everything was green, I simply could close it and it worked. Yeah. So it seems a bit erroneous, at least at the moment where I did the demonstrations. And once this went through, we see all the data in our KQL database with the data preview, and we see that there was data in, so everything works. That's great. Now we have one destination. Eventline versus Eventstream versus pipeline versus Dataflow. Eventline and Pipeflow and, well, no. Data stream, right? No. Event stream versus pipeline versus data flow. When to use what? So I've created like a decision chart, right? First question is, does your data arrive continuously? If yes, you guess it, you are on the real-time event stream boat. If not, different question. So let's follow first the yes path. Do you need in-flight transformations? Do you need to change your data while it arrives? Say yes. Then you are in event streams. And say, no, I don't need transformations. The next question is, do you need multiple destinations simultaneously? If yes, you are on the event stream side. If no, you are still on the event stream side because you need streaming, you need no code, and you need, most important, real time. And say, no, I don't need real time at all. Okay. Do you need orchestration like sequence, like retry? No. Do you want to provide self-service ETL for analysts? No. Then you are on the data pipeline area, just traditional stuff. The same way as when you say, I need orchestration, but I don't have real-time data, then data pipeline. When you want to provide self-service ETL, no-code ETL for analysts, then you are on the Dataflow Gen2 boat. So it's pretty simple. You see, once you choose real time, you end up in Eventstream in either way. Yeah? These are all the 3 targets for Eventstream. When you say no, there's no real business case for Eventstream, but you can decide whether to go with pipeline or with Dataflow Gen2, depending if you need self-service ETL or not. It's that simple. When you have real time, you will go with Eventstream. Now we ended up with one destination. You see all the data is in here. We can check the JSON that was submitted, so everything is great. Let's go back to our event stream, and you see we have the small connectors, and we can reconnect. We can delete that connectors. We can then add different items. And then we can reconnect all that, right? So in this case, we will first add a filter and say, okay, we will filter for events, and we can rearrange it a little bit. From time to time, you will see, I kept that in that video because you see that the connector is missing. And this happened from time to time. And the simple trick is reload your browser window, and then the connectors will reappear. Just when you experience that, you know that. So we need to name the operation. We need to select a field where to operate on. In this case, we will the number of bikes. And if the number of bikes is less than 5, then there are very few bikes at that bike point. That's not good. So we will filter that out. And then we will manage fields, which means we will select fields, and we can also map the data types. You might remember that from the drawing. We can that's the bike point ID, not the station ID. But it's a bit small. You see that I need. There we go. There's a bike point ID. I didn't get that at the first point. There you go. So we can select the fields that we want to keep. It's like a field filter. And once we have everything that we want to keep, we can save that. Then we not filter only by bikes that are less than 5 bike points, but we also filter the fields, right? And we can edit the single items and rename the fields, and we can set the data type if we want to. We don't want to do that, but we want to rename the fields. And once we have done that, we can connect, or we can add other options. In this case, we will add a derived stream, which could be also named second stream. We create out of that filter a second stream. These are the critical bike points. And let's move the stuff a little bit around here. And once we have arranged that, we can add our new target. You see that here with the event house. So we can say, okay, we want to write the critical event points to the critical data, the critical byte points to the event house. And we need again to say which kind of destination name and workspace and event house name and the KQL database. Remember, there was the thing with that table schema, so we need to save that stuff and we can rename it, make it a little bit more. These are the critical byte points. Yeah, exactly. That's good because we cannot name the things twice the same. We should work with suffixes or prefixes, and it's for that. Now we can publish that thing, and it will create again the schema. And once we have created the schema, we can create the table out of that. You all know that. So I finished that, and we can check, and we should have when we refresh that. Yeah, I need to refresh that over there. We should get our bicycle events and our critical events, but that takes some time, so that's okay. And we need to cross-check whether we have configured everything. You see there's the filter. We get all the details out there. It's a live view, that's okay. So that looks good. We see the filtered items, so that seems to be quite okay. And we have the managed field, which is quite and there you see the point. You see, it's still loading, so it takes some time, as I said. And now we can hit configure, and we can assign the table, and the table now is critical byte points. So you see, when we just jump to the event house, nothing is there because first we need to configure that, and second, it was still loading. And now we have again this wizard experience where everything is green, and when we close, we need to say, okay, yes, cancel, and it works. So that's okay. It's green now. And after some point, you see after some seconds, we have the critical byte points here. It's still empty, so it's still loading data, but at some point, it will have the data from all the critical byte points. There you see, now there are the data, and we can check the number of bytes is less than 5. That's the point here. And that's our metric of success. So we are back in the event stream. We can edit that event stream, and we can delete the different connections. And now we can create a next target, right? So this is our connector, and when it's not there, just remember you need to reload that stuff. Well, it is like it is. So we can create a lakehouse for storing the archive data. We can name our target and select the appropriate lakehouse. In this case, we don't have a lakehouse, so we create new. Once you have hit the drop down, the link will not work, so you need to scroll around a little bit, and then you can create your lakehouse. This is a bike cycle all data, so because all data is going in there. And now it's creating the lakehouse in the backend. That's pretty cool. We need to name the delta table. We do that. Yeah, you see it's the same issue with the link. So I need to click over here, and then I can click over there. And we can select an existing schema and name the delta table. That's done. That's cool. Save. And now you see we have still some not connected lines here. And we can connect from the default stream multiple destinations, and that's the beauty, right? So this is simultaneously written, as I have explained, and it's pretty cool. So we now simultaneously write in different destinations, and we can even add a third destination, again an event house, for, let's say, some other events that we want to store. Same game, you see, we're putting the data in here, and once we publish that and create a little bit of space here. We see that, that all the 3 destinations are here, and once we publish it, we can create the destination table, which in this case is the raw destination table that could serve at some later point for example, a data activator connection or whatever, right? So, well, that's there's some error, but it still works. That's like the round trip, and you see the power of event streams. It's pretty cool. Once you get everything in place and you get an idea of that, it works really nicely, and I can honestly highly recommend that. So now our data event stream is like flowing, and you see we start from the bicycle data, we go through the default stream, we have 3 different targets: Lakehouse, Eventhouse, and then we filter, that's the 3rd target. We select the fields, we rename the fields, and at the end we write into an Eventhouse only the critical data. So that's our complete walkthrough. And you see all the data is in here, right? We have the bicycle events, we have our critical events, and when we go to our event house, then we will see that we also have our data in the event house and the DBO schema. There we go. This is the bicycle or delta table with all the bicycle data in the Lakehouse. So we just said that when we have continuous data, I said real time, but in the end it's continuous data, you will go with Eventstream in any way. There can be errors in Eventstream, right? That's why you have an Eventstream live view, which is great, right? So first of all, source node is connected. That's important, right? It's the source connected. You will see that there. Then you have these Eventhouse nodes. There you see runtime errors. Let's say that's 0, and you will see conversion errors. Let's say you have 3 conversion errors. And then you see the event stream incoming. Let's say that's 1K per second, and outgoing, let's say that's also 1K per second. So let's draw from there on. Let's first ask, well, what are common errors? So we said we have 3 errors, right? So very common is a deserialization error. So the event format doesn't match the schema. Data conversion means you have a field type mismatch. Let's say you have a string instead of an integer. What are the solutions? Solutions. For deserialization, use schema registration. Schema registry. There you can predefine the schema. For field conversions, manage fields. Manage fields. That's an activity. Manage fields, where you can say, I want to set the field type. So this is an integer, for example. And regarding the capacity, incoming, outgoing, there, if you have too much data incoming, outgoing, there can be a delay, a lag, processing lag too high. The very simple solution is increase You guess it, capacity, which means your fabric capacity. So let's say go from F4 to F8 or something like that. Very simple. Let's talk about the community question. So, well, overall, this is quite positive reception. No code approach. Top question is, can I connect my existing Kafka application to Fabric event streams without rewriting it? The answer is yes. You have two paths. First, add Confluent Cloud for Kafka as a source in your event stream. It connects natively to Confluent. The second, and this is kind of underappreciated, every event stream exposes its own Kafka-compatible endpoint. You simply need to copy that, and your existing producer simply changes the broker address and authentication to the event stream endpoint. Same Kafka protocol, no changes. Microsoft built event streams on top of Kafka of Azure Event Hubs internally, which is why the Kafka protocol works out of the box. Next, top question. What happens if my event stream goes down, the destination? Do I lose events? Event streams guarantees at least once delivery. If the destination is temporarily unreachable, events are buffered and retried. You won't lose events, but you might get duplicates. And I promised you during the architecture part that we will come back to that, because the query processor of the event stream and of the event house has included duplicate detection, which helps you a lot. So you can simply connect, that's it. For Eventhouse, this is fine. The KQI engine handles the duplicates for you. For Lakehouse, Delta's transaction writes also protect you against partial failures. The maximum retention time is 90 days. That should work. Every event is buffered for 90 days. What you will miss is when you add a new destination to an existing event stream, it only receives events from that moment forward. So there is no backfill from historical events that were already processed. When you pause it, it will continue from the current time, not from where it's paused. Event stream versus mirroring versus data pipeline. I want real time from my SQL Server and Fabric. Which one? 3 tools, different granularity. Mirroring is full table replication. Great. For I want a live copy of my SQL Server near real time. Full table sync, no transformation capability. Event stream via CDC, row level change capture. Every insert, update, delete flows as an event. You see the change type, the old value, the new value. With Dataflow, raw CDC events are automatically converted to analytic-ready rows. Data pipeline, batch copy on a schedule, no real time. So the rule is need a live copy mirroring, need to react on individual row changes, event stream with CDC. Next question. My event stream shows green in live view, but data isn't arriving in the event house. Why? A classic gotcha. 3 things to check. Ingestion mode. If you choose event processing before ingestion, did you configure the processing canvas? An empty processor canvas will not pass any events through. Schema mismatch. There might be a schema mismatch. So check the data insights for deserialization errors or table mapping. In direct ingestion mode, verify the target table name and column mapping. If the table doesn't exist or if the column mapping is wrong, no data will arrive. Next question. How much does EventStream actually cost? Well, it confuses me. We have 4 meters, right? So 4 meters, flat per hour. 0.2 CUs per hour charged when events are flowing. Data traffic per gigabyte. 0.34 CUs per hour per gigabyte. Every gigabyte flowing through the stream, 500 megabytes a day, it's around 15 gigabytes per month. The flat per hour is charged and the idle time is 2+ hours. Then the charge goes down. Processor per hour starts at 0.7 CU per hour. This is a transformation engine. Auto scales up under load. This is where costs can surprise you if the throughput spikes. Connector vCores, 0.6 vCores CU per hour per vCore. It's only for third party. So essentially you have three. One is the flat per hour. It's with a 2-hour idle time. The second one is traffic. The third one is processor per hour. And this is the most expensive one. So you need to keep an eye on that. Pro tips from the community. Always enable enhanced capabilities. They are enabled by default now, so this is no longer really important. Start with sample data. That's easy to learn. We did that also in our demonstrations. Derived streams are individually subscribable. So your teammates can consume your derived stream from Runtime Hub without accessing your Eventstream item. That's pretty cool. Pause individual sources or destinations without stopping the whole stream. This is great for maintenance windows, for example, on destinations. And the Kafka endpoint works both ways. Eventstream can expose a Kafka endpoint for consumers and not just for producers. So this was about Eventstream, more a demo-heavy session this time. I hope you enjoyed it. When you want to get a notification once I release a new video, just hit subscribe on my YouTube channel. And thanks for attending. See you next time.